Hey everybody, today we're gonna learn noble gas configurations. So let's start with noble gases. What are noble gases? So noble gases are the elements in the periodic table. They belong to group 18 of your periodic table. See that? Helium, neon, argon, krypton, xenon, radon, all of these are known as noble gases. So what is so special about noble gases? They have full s and p orbitals. For example, if you see the configuration of neon, it's 1s2, 2s2, 2p6. So the highest energy level, which is n equals 2, is completely filled. So s and p both have the max number of electrons they can have, right? And look at the argon. Argon ends in 3s2 and 3p6. Again, a full s and p orbital. Okay. So how do we write noble gas configuration of an element? So first step is locate the element in a period and the group. For example, whether the element is in P block, D block, S block or F block, and then you locate the period of that element. So we need to know which block and which period the element is located. Next, we find the noble gas in the previous period. For example, if the element is in the third period, we will use a noble gas in the second period. So one period before the period of the element. Okay. Then we write down the noble gas that we just found, right, from the previous period in a square brackets. Remember, no parentheses. Then after you write down the noble gas in square brackets, you write down all the extra electrons, which are usually the electrons in the same period that the element is located. So these are the 4 steps. Now let's do an example. So this is how we do this is the format, right? You write down the noble gas in the previous period and then the extra electrons, which are usually in the same period where the element is, right? So let's write down the electron configuration of tungsten. Right? So first step, tungsten is in which period or which group, right? So let's see, let's locate tungsten. So tungsten is in, here's tungsten. It's in the D block and it's in the 6th period of the periodic table, right? Now if tungsten is in 6th period, we will use the noble gas in the 5th period of the periodic table, which is xenon. Do you see that? Xenon is in 5th period. So we will write xenon in square brackets. So we will write xenon in square brackets because this is the 5th period noble gas, and writing the xenon, it already takes care of 54 electrons, right? And tungsten has 74. And then we come back to the 6th period in which tungsten is located. We write down all the all the the configuration of all the elements before it. So we end in 6s2. So let's write 6s2. Then after the 6th period S block, we enter the D block. Now look, this one is tricky. So before tungsten we have that yellow line. So this means we complete 4f series before we go to the 3d orbitals, right? So we will write 4f14 because that is complete, and then we go back again to the 5d series. So this is D1, D2, D3 and D4, right? So tungsten will be D4. So that would be 5D4. So this is how we write down the configuration of an element, right? So let's do some of the problems from worksheet number 4. Let's write down the configuration of iron and then write down the configuration of iron in noble gas notation. We also have to do the orbital diagram of iron, right? So let's start with the orbital diagram first. So iron is in which period? So iron is right here. It's in the D block and it's in the 4th period, right? So we will write down all the elements before iron, right? And in terms of noble gas, we will use the noble gas in the 3rd period, which is argon, right? So if I had to write the noble gas configuration of iron, let's first draw the orbital diagram. So we have 1s2, 1s2, 2s2, 2p6, 3s2, 3p6. Then we have 4s2, 3d6. So this is the configuration of iron, right? And then in noble gas notation, since iron is in 4th period, I will use the noble gas in the 3rd period, which is argon. Already takes care of the 18 electrons. So this part that you see is argon, right? And then we write down the extra electrons for iron. So that would be the noble gas configuration of iron. Now what if we have to write down the noble gas configuration of krypton, which is another noble gas, right? So how do we write down the configuration of a noble gas in terms of an other noble gas, right? So now let's first locate krypton. So krypton is right here in period 4, right? So we will still follow the same rules. We will take the noble gas in the previous period, that is argon, and then write all the elements in the 4th period. So write down the electron configuration in the noble gas form. So argon we will write with argon, because krypton has 36 electrons and it's in period 4. So this is the noble gas in the 3rd period. And then write down all the extra electrons starting with the 4s block. So we have 4s2, then we have 3d10, and then 4p6, right? So after argon we have 4s2, then 3d10 and 4p6. Remember, argon always, or any noble gas, will have full s and p orbitals. Now see, n equals 4 is what the period number of noble gas krypton is, and it has both s and p block that is fully filled. Okay? So this is how we write down the noble gas configurations. Hope that video is helpful. Thank you.